plan is to go over some considerations I made for the performance and some more practical. I'll get into it. So we got about a 5-minute introduction. I'll go over the project for 35 minutes. Jason wanted me to have an extended Q&A time in case we had any questions about the project or life or school or really anything. A little bit about me. I always thought trying things was the most important thing. You succeed at a couple, you fail at like hundreds, and it kind of works out. I was in half a dozen clubs. I was leader of the game development club here for a couple years. I don't know if that's still around. Kind of merged into the yeah. I think kind of merged into the house system, and I know Travis does a lot of stuff with that kind of thing. In terms of internship, I just asked Ted Kosan. Is he still here?
He retired last fall.
Oh wow,
last spring.
That's awesome. For an internship, I was part of the I forget what they're called. Just the tutors here. Kind of worked into them, and then game jams are probably my favorite part of coming to school here. I would try to go to as many as you can. Even if you don't make anything cool, it's just a great experience. I'd recommend coming into the building. I don't know if people still do that, but I'd recommend going home to sleep. We didn't always do that. So after graduation, I had a job hunt for a while. It was a lot. I started like February searching for jobs my senior year. Better start earlier. I started at this place called Battelle Memorial Institute, where I actually ended up back. I was there for about a year and a half doing sort of back-end server stuff. I volunteered for a year at this place called AmeriCorps City Year during COVID. I was an assistant teacher in a second grade classroom. I ended up working at a summer camp for 4 or 5 months. Went to grad school for a little while in economics, trying to do some data analysis. Got a job at a couple other places. Went back to college to study education, which was really fun, but I ended up not pursuing that, and now I'm back at Battelle. So I only bring that up because, as you graduate college, get out into the workforce, post-college life, some people do one thing for a long time. A lot of people do a lot of things, and kind of just works itself out. In terms of hobbies, I recommend getting into them. Once you get out of school, you got a little more time. Not more time, but just more structured time. I'm quite into rock climbing. I still do hobby game development as I can. I'm a bit of a Go player now, if you've ever heard of it. My friend Ed is the 5th best player in Ohio. 4th best. I love writing music. I love writing stories. Just try to do things that aren't just games, and then you actually end up making better games anyway. So that's all I wanted to go over for myself. So I will do some live coding. Hopefully it works. Okay. Can everyone see the text, everything on the terminal? And no qualms. Okay, sweet. So, first thing I'm going to do, who here, raise your hand, has used Python before? A lot of people. Everyone but Travis, you just left. It's okay. You never quite got the hang of it. No, I'm kidding. Who here has heard of virtual environments before? Okay, do we use those in school?
PyCharm creates them automatically. I don't know what they do, but I use them.
Okay. Has anyone heard of Conda? Anaconda, Miniconda, etc. So a virtual environment in Python. So the thing about Python is that if you just install it normally, it installs to your global system. And then if you install a library, it installs to your global system. And then if you want to run a project that has a different version of that library, it might not be compatible and might run into bugs. So Python recommends doing these things on virtual environments to just have basically a local copy of Python wherever you want. So Conda is a way to manage those things. And I'm just going to make a Conda environment. install the Python libraries. These are all the libraries we used, not very many. This one is, I have a mesh that this just helps load. I have Numba, which we'll get into. These are some math libraries that help with things. And of course, Pygame to do the actual rendering of the screen. So I'm going to make an environment. It's going to install everything. I just want to run it so you know it's just regular Python, nothing fancy. Well, libraries are kind of funny. File. Has anyone seen this requirements.txt before? You know what that is? Yeah, awesome. So this is like a standard way to keep track of all the Python versions, the library versions you're using. So then you do something like this command. So it's telling Conda to create an environment named SSU based on this requirements file. And this is just telling it where to get the downloads from, basically. So it's going to take a little bit. It's going to ask, you know, all these libraries. Are you good with these? And I'm just going to say yes. And it should download pretty quick. This is kind of cool because you can kind of see all the dependencies of all your stuff. So we have all these TTF fonts from Pygame, Fluidson from Pygame. You know, all these SDL things, SciPy. Yeah, mostly they're Pygame dependencies. Okay. So then all you have to do is kind of activate SSU. And so has anyone seen this Python-M thing before? Okay, we got one. So this is like a way to organize your Python projects. And I'll talk about it in a second. But let's run, see how it goes. Fingers crossed. Work. Tested this like 10 times. Don't laugh at the quality of my graphics, especially Jim. He's gonna laugh. Okay, here we go. We got our real-time 3D graphics rasterizer. Pretty good FPS. Got about 900 triangles. Yeah, so yeah, I grabbed a Kirby mesh from Spider's resource. Yeah, so obviously this is pretty atrocious. So I want to do some examples of how to profile code and make it faster. That's the idea. And then it'll run at 30 FPS, I promise. Okay, so first I want to go over, I'll just close this real quick. Part of this, the reason for this talk is because, so at Battelle I write simulations, not games, but simulations. Often they're not real-time simulations, but we have a lot of models. Models are just programs that run math code and get outputs. And we have a lot of them, and we want to run a lot of scenarios, so different inputs to the models. We have like 10 million scenarios to run. Each one we want to run 500 times minimum. And then we want to compile all the data into like one report and give it to our client. So that's the idea. So performance is important to us. It's not as important in terms of real-time setting, but we still want to get as many realizations per second. So these are some of the things that I think about in my job, especially when I'm writing anything in Python, which I actually end up doing quite a bit. So the first thing is, I have a folder here with my mesh, Kirby. I just grabbed it in Blender, did a little editing. Blender's pretty great. These are all profiler outputs that we'll talk about. This is my nice README. So if you have a Python folder with a bunch of Python code, you can put this thing called an init.py file, and it'll make it a module. So this is how modules work. Pygame has one of these. And it just makes it so you can run python-mtalk, and it also means you can import relative to your pathing, and so I'm importing all the GPU stuff. The GPU one, this is all the GPU code. I named it that. It doesn't use a graphics card. It's all CPU based, but it's emulating a GPU, so I just call it GPU. It has its own init.py, and it kind of imports everything it needs. Okay, so let's talk about a profiler. Has anyone heard of a profiler? We got one, we got two. Is anyone in the optimization class, the gym?
That would be
well, some of the people have their hands up.
Some of the people.
Yeah, I guess some people should.
Okay, so someone explain to me what a profiler is in your own words.
It looks through all of your different functions and methods and whatnot and checks how what many cycles they're taking. That's what we saw at least. We just worked with them.
Oh, awesome. Yeah, so, I mean, I'm no expert on how profilers work. But basically, yeah, it'll tell you how long your code is running. You can configure it to say how much memory it uses. And you can configure it to, oh, we'll just run it. So let's profile this code. We think it's a little too slow. Let's pretend we think that. I think it's great. So in Python, you can easily run a profiler. There's this thing called C profile built into the standard library. You can use it to profile any Python code. I'm going to give it this, and then I'm going to redirect profile. Let's call it 1. So what this is saying is run Python, run the C profile module. It's telling C profile to run our talk module, and it's redirecting the output to this txt file. So we can run it. Usually you want to give it a second. Okay, that's probably good. So let's look at this output. Okay. So this is a pretty basic output. You can run the Python profiler in a lot of different ways, and you can output more advanced things, but this is often good enough. So you kind of got to know what these columns mean. So this is the number of calls. So you can see this function gets called 1 million, almost 2 million times. This one only gets called 1 time. Oh, what function is it? Oh, it's the main function. Of course it only gets called 1 time. Looks like we call render 70 times. So there's two basic concepts. There's the cumulative runtime of the function, and in Python's case, it calls it the total time of the function. So the cumulative time is how much time it spends in the function, and it includes any sub-functions that it calls. So for example, main.py basically has all the time, but actually executing code in main.py, very little. Like nothing actually happens. It calls, subroutines and sub-functions and yada yada. So, but we see this thing, triangle blit. It is taking 6 seconds of our runtime. We have a total of 15. We have this thing, compute barycentric coordinates, also taking a lot of runtime. Not as much per call, but we are calling it 2 million times. So who here has heard of a hot path?
We were talking about it the other day.
Yeah, hot path is important. So the basic idea is, the old classic, 80% of your runtime comes from 20% of your code. And the hot path is like the 20% of that, where like almost everything just burrows into this one hot path. And it's usually like a loop that iterates a lot, and it's important that it's really tight and really fast, because if you optimize the crap out of, I don't know, this thing, 2-screen, it won't matter because it's like a negligible runtime. But if we optimize one of these two functions, well, we can get some real performance increase. And there's actually a really clever use of the library. One of the points I want to get across in this talk is to use your libraries. Don't try to just roll your own stuff because you think it's fun, unless you just want to have fun. But if you're trying to make like a production system, it's generally you want to use your libraries. So I have this one. It's called Numba. And if you've never heard of Numba, basically Numba will, you give it this. And so what this is a JIT. Has anyone heard of JIT, just-in-time compilation?
Yes.
Yeah, so this is a big thing. This will actually take this Python function, and on the first call, given a set of, well, I get into that too much. Does this syntax make sense? Has people seen this?
Yeah.
Okay, this is just saying what. Yeah, so it's a type hint. We're pretending it's a type language and telling our IDE that it's going to be this. Okay, so it's going to compile this down to optimize C code in theory. And let's just put it on both of these. This is actually going to be quite significant speed increase. So we saw our two compute barycentric coordinates and triangle blit. Let's see what happens when we do that, and then I'll talk through it real quick. Okay, already better. That's great. So what are these things doing? So triangle blit, it's not the best code in the world, but basically we give it the coordinates of a triangle. It'll loop through the y positions of that triangle, and for every y position there's a bunch of x positions that need to get rendered, and then it blah 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 does graphics, and it writes a color to the color buffer and does something like that. I don't want to get too bogged down in the weeds of the graphics, but basically this is the thing that actually writes into our memory, and Python is obviously very bad at that, just doing a loop and writing values. And in fact, that's kind of a annoyingly slow thing to do, writing to disk and writing to RAM. It's anytime you're like dealing with writing things, it's very slow. So we optimize the C thing, or we use JIT. Can be barycentric coordinates. It does some math, so Python's like okay at math, but it's not that good, especially when we're calling it 2 million times, because let's look here. So triangle blit is called once for every triangle, and we were rendering 900 triangles a frame. Compute barycentric coordinates is called for every pixel in the triangle. So this is like the most called function we have. So even though it's a relatively fast function, which we saw here, 3 microseconds, it can still be faster. Okay, so we did that. Let's look at Profiler now. Notice that I am calling it number 2. You always want to keep track when you're optimizing of the past profilers you've done, because you might do something that makes it slower and you forget that it's slower. So you always want to like backtrack and compare. Now, obviously we have this FPS counter and we can kind of just tell. But in the latter part of the talk, I'll give an example of something I found this morning where I was trying to do this thing where I put bad code in, and it actually made my program faster. So you always just want to be in the back of your mind thinking about keeping track of things. So okay, what do we got now? Okay, so, well, draw triangle got a lot better. I don't see compute barycentric coordinates up here at all, so that's basically not a problem. I see this thing interpolate x, but it's really slow. So at this point, we can try to optimize the draw triangle function to make it faster, but I'll just say, we don't need to do that. So just a little pop quiz. What would you try next to speed this up? Like obviously we're running 13 FPS. We are running at, where is it? 640 by 480 in the resolution, and we're running 5 meshes. Each mesh has about 180 triangles, and we can see we have 900 of them rendering. So this is an accurate count. It keeps track. Every time it renders a triangle, it increases this. So just curious what people think, what they would try in terms of next steps.
We're new here, so we have no idea.
Oh, that's okay.
Yeah.
Oh, I don't know. If you're new, you might have some good ideas. Yeah, what's up?
I haven't gotten a good look at the code, but my first guess would be instead of running the initial calculation function over and over, maybe try to improve it so it increments slowly, so you're not running it each frame. You're just adding on to the initial counts each frame.
In terms of the triangle count, or what more specific?
I'm not sure.
How to say? Yeah, so that in general is a great idea. If you have computation, like for example, one thing that I'm a little sad about. So I have my mesh. This is kind of going to give you a bit of a hint. In here we can do something. So yeah, we have the world transform. which is rotation matrix times the translation matrix. Then we multiply by the projection matrix, blah, blah, blah. This is what makes it so that the Kirby's appear where they are on screen. And so then we multiply each vertex by the transform as we draw the triangles. So this is a bit inefficient because we could be multiplying the vertices before and then only looping through them. But our profiler isn't really saying that our mesh code is to be the next area for concern. It's really this draw triangle that's taking the bulk and maybe this number of calls. So one thing that you can do is not waste computation. So how to say? This isn't really a performance optimization of a function thing, but you know, if we're running this and we are only rendering 900 triangles and we're always rendering 900 triangles, well, some triangles that we don't even see that are behind the Kirby are still being rendered. Does that make sense? So we can actually just skip a bunch of triangles. So first of all, we can skip ones that are off screen, and we can skip ones that will never be seen. So the ones that are off screen is often called a clip. And I have a little code. So here we go. We have a function, and you can probably guess this is a little slow. So let's put one of these on there. This kind of just makes most of your Python code faster, but it's kind of annoying to work with. Anyway, so we can start and use this. So to use this, we can go to our mesh. And so instead of drawing the triangle, let us, if is in clip. Okay. So this is saying if the x-coordinate is in between, it's technically the w-coordinate, but if it's in between these two things, if it's on screen, then we'll render it. And if all the coordinates are on screen, then we'll render it. And if it's not if all the coordinates aren't on screen, then we'll just discard it and we'll just skip computing draw triangle. Because draw triangle is our slow function. If we can skip it when we can, it's actually a lot more useful than you might think, just not running a function. Sometimes you don't have to. Let's see. Okay. Yeah, so we're getting a bit more FPS. We're getting a little visual artifacting, but Jim's not allowed to laugh at that. We're still not getting a lot, so there's actually one more thing we can add to this.
Are we drawing triangles that are behind other triangles?
Yeah, you know, we are. We're not telling it not to do that.
Probably do that.
We should probably do that. So, well, one thing we're doing is in yeah, so in here, we're only drawing to the color buffer if we are less than the depth buffer value. So this keeps track of what's in front of what. And so we can actually use this in our clip, wherein take these. You're also not allowed to laugh at this code. You can laugh at other code, I promise. Okay. Oh no. Okay, so now we can say if A2, which this is the z-coordinate, so the z-coordinate corresponds to the depth buffer, and if z2 is less than the depth buffer at A and B, well, then we're in the clip, and so we should render it. So in theory, we shouldn't see any visual difference, but we should see a big increase in speed because now we're not going to render triangles we can't even see. Okay, and we did get a decent increase in speed. Now we're at about 18 FPS. Last time we were at about 14. We can actually add that engine thing, because nothing in here is doing any special Python stuff. It's literally just comparison operations, and that's very fast, so engine can handle that. So we can run that too. Now we're getting up into the 20s. We're starting to get to actually real time. Okay, so let's run the profiler again. And this is kind of the process of optimizing. You know, you kind of just try things and run the profiler. I know you might think, oh, the FPS went up, though it's better, but profiler can show you things that you might not expect. What do we got now? Okay. So this is all looking pretty good. Our draw triangle, let's see. So per call, we got about 40 microseconds. Still about 40 microseconds, so that makes sense. We didn't change that at all, but our number of calls, let's see. We're calling render, let's see. 209, 300. So we're calling about 182, which is how many faces are in the mesh. And now we're calling, oh, significantly less. Now we have 1, 3, 4, 3, 4, 1, 1245. So now on average we're only calling it 100 times. And so we've basically gotten the same visual clarity if you forget that some of the triangles are off screen. So in a real rasterizer, obviously you would draw part of these triangles. It's a little more nuanced than you might think to do that. So I didn't do it. Well, I did it, and then it crashed my program. So I took it out. But we're basically getting the same visual feedback, so we're basically getting the same result, neglecting these things. But we're calling the function, half as many times. So there's one more optimization I want to do in terms of this live coding session before I just sort of break down and go through each step of this project, sort of file by file. What do you think we could do to get a very similar visual quality, but run a quarter of things? We want to try to reduce what draw triangle is doing. And we can get basically the same visual quality, but do a quarter of the work. I'll just give a few seconds for thinking and then I'll tell you. You can just guess too, if you don't know.
Are you calling backfaces?
No, but I'm not going to do that because I didn't want to figure out winding order. Actually, I have a question for you after this. There's a very subtle bug that I had that I fixed by just moving code around, and I don't understand.
Just fix it.
That's what I said. But yeah, so calling backfaces is like, so every one of these triangles, in theory, has a direction that it's pointing out, like my hand, like this. And if it's pointing away from the camera, well, we probably can't see it, so we can just not draw it. But we are not drawing triangles that are behind other triangles, so that's kind of like a backface. It's not. You really should call backfaces, but I didn't do it.
Can you run multiprocessing?
That's a great question.
I mean, that's not what you're looking for, but that would make it faster, right?
Remind me to go over multiprocessing after we do this last optimization. Okay, I'll just tell you. So this is actually twice the resolution of a Nintendo 64. So we could go to what the resolution of a Nintendo 64 is. So let's see, memory. I Okay, so let's just pretend that 320 by 240 is about the same as 640 by 480. And let's run that. Okay, now we're talking.
Yeah.
But actually
That
this
was
is a common thing. You lower the resolution of your graphics settings. But we should probably scale this up. So you can very easily, in Pygame, one of the things you can do is create a buffer. Well, I call it a buffer. Pygame calls it a surface. I guess it's technically a surface. And then, okay, so we have our buffer, and we can say, please tell me if they're over here. Yes. The best programmer of all time. I recommend you tell yourself that at least once a day. I know when I was in school, I said, I'm such a terrible programmer. But, you're a good programmer that occasionally makes mistakes. I'm sure. Okay, so instead of blitting our surface directly, we can scale it and blit this thing. And then it will basically look just as good. Yeah, it's basically just as good, right? Well, so for my purposes, yeah, this is basically just as good. If I really wanted it, I would put a little blur effect on it so you couldn't really see the pixels. But a lot of times you got to think about what actually matters for your output. So for my job, we run a lot of random inputs. So we could compute down to say 12 decimals of precision, but we're just trying to get a ballpark estimate of what's going on. So we only run it 500 times, and we have, let's say, 2,000 inputs that all vary randomly. So we're really only trying to get an average number out. So sometimes we can just do a little bit less on the numeric precision and get a decent result. So sometimes you got to think, what actually am I trying to do here? And if rendering it and scaling it's good enough, maybe good enough. Okay, so now officially we have definitely a real-time rasterization, 3D graphics engine type thing. We're rendering meshes whenever we want. We have translation and rotation, so that's basically everything. We just need to add scale. And scale is trivial to add. We could very easily move the camera around if we wanted to by doing more of this translation and blah, blah, blah. So, okay. Before I go any further, are there any questions on the sort of optimization type process we went through? Okay. So, Jason, do you want me to stop here, go over a little more code, because it's about 20 minutes? That's what you wanted for...
We could do a little bit and then maybe come back to it if they run out of questions.
Yeah, sure.
Is that okay?
Yeah, so Jason wanted me... I'll just leave this running. By the way, I was originally going to do CUDA acceleration on this, but I have a MacBook, so it didn't work out. But there's a library you can get that does all of the NumPy operations, and I want to get into it, so if you don't have questions. But Jason wanted me to give some time. If you have any questions about anything you're working on in class, I'll just tell you the answer. Don't tell Jim I did that. But questions about post-college, life in college, things you want to know about Jason, really anything.
Can I start with one?
Yeah, of course.
So I really liked on your second slide how you pivoted multiple times in your career. Was that a hard thing to overcome? I remember you as having a pretty definite goal of what you wanted to do, but did you pivot it a couple times?
Did you? What was my goal, Jason?
I remember philosophy was an important life goal. Wow. To be a philosopher living on a mountain.
Yeah, that does ring a bell. And then I read the book Into the Wild and thought I shouldn't do that anymore. If you ever read that book, I recommend it to all the young people to read if they're like, I can just live off the grid and live in the mountains and raft down a river and die when I ate a potato in Alaska. It's a pretty cool book. Yeah, it was. So even in college, you probably remember, I changed my degree like 3 times. Well, I was always in the games degree, but I wanted to double major with at the time it was a CET degree, you still have that?
Mm-hmm.
So I wanted to go into the computer engineering technologies, do a bunch of hardware, and I took maybe 4 or 5 classes in that program, maybe 6. And they were awesome, I loved them, but I just didn't have enough time. I wanted to make more games, so I just quit that. And then I was like, I'm not doing enough. So I had a burrito bowl really quickly. They were pretty good. I got a little burp. Anyway. What was I talking about?
I think a lot of students kind of question themselves, like there's some imposter syndrome when they're starting a job, things like that. Like, just any like life advice for them, I guess. Just is it a healthy thing to question yourself?
Well, the first thing I'll say is all advice is bad advice. Always remember that when someone tells you what to do. They don't know what they're like. Nobody knows you like you do. So you just take my words with a grain of salt. You know, I don't know your life. But how to say, I think in terms of imposter, when I've heard that, it's like
Among Us?
Among Us, yeah. Well, so when I first started at Battelle, I was doing back-end web server development, which I don't know if you do that now, but I didn't learn about that in school. We were using all these fancy words like .NET and dependency injection and XUnit and I don't know, arranged active cert, blah, blah, blah. And you know, my software engineering class wasn't very good. That teacher's not here anymore, so I assume it's better now.
Yes.
And so it was like kind of scary because I didn't know what was going on. But one thing I'll say that I've learned is that basically anyone who comes out of this program knows how to program like really well, like way better than you think you do in terms of other people coming out of like degree programs. Like a lot of people who graduate, they don't know how to like compute the factorial of 5. I assume you know how to compute the factorial of 5. I assume you think I'm lying when I say this because I thought people were lying. It's not. It's not a lie. It's very true actually. How to say? So for me, I had a really good mentor. So I would try to find people that can be your mentors and can show you and calm you down so you can kind of learn and figure it out. Because I think anyone from this degree can basically figure it out. And then it just comes down to an experience thing where after you like, you know, Mike Tyson has that quote, everyone has a plan until they get hit in the mouth. You know, once you get hit in the mouth a few times and you get back up, it'll be fine. Does that make sense? So in terms of changing my career, like for me, I just got really bored. And then I just had to change. So it's like, it was almost like I couldn't not do it. But I assume some people aren't like that. Yeah, that's what I'm saying.
I guess we're doing like a kind of generic
Yeah.
feelings of AI.
What kind of AI?
Just in general.
Feelings of AI?
Yeah, just in general. Yeah.
Well, I'm pretty annoyed that everyone thinks when you say AI out in the wild, now people have heard the word and they just think it means ChatGPT. Because, you know, when I took AI with Dr. Dwayne Skaggs, is he still here?
Mm-hmm.
Where is he? Come on, Dwayne. Anyway. I learned about all sorts of cool techniques, like evolutionary algorithms and just like neural networks in general. In terms of, let's say, ChatGPT, I use it at work a little bit. So let me tell you how I use it, because you've probably heard people tell you not to use it. I'll tell you not to use it, but I use it. But you shouldn't use it, at least a little. So one thing that I find really helpful, so I was doing a project in MATLAB. And in MATLAB, don't know if you ever used MATLAB, but it's pretty cool. Except it just didn't open, and I just didn't know how. And I was looking online, and no one could tell me. And then AI was like, "Oh yeah, clear the cache." And I was like, "Okay, how do I do that?" And it said, "Well, if you type this command in MATLAB, it'll tell you where the cache is, and then you can delete it." And I said, "Well, it won't open." And they said, "Well, if you can't open it, clear the cache." I was like, "Okay." But it did help me figure out that I should look for the default cache location, and then we got around to it. And I have had it write some code for me because it would have been so boring. It would have been a piece of logic. Now, let me put it this way. A lot of times when you have the thought, man, this code would be so boring to write, it's probably just built into Python. So I could have looked, and it was built into Python. But I didn't know that, so I told Annie to write it for me. Well, Annie's like our proprietary AI that we use. Because we're not allowed to use ChatGPT, so they have a private server with ChatGPT on it, and they call it Annie. And then Annie wrote it, and it did work, except it didn't work. And every time I tested it, it didn't work. And so I still had to fix it, and it was annoying. One thing that I think is cool about it is that I was writing an application for this program at my work. It's like a new work opportunity there. And I had it proofread my application, and it was pretty good. But most of the time, it just tells me things I already know, and it has buggy code. Well, those are my feelings on AI. Does that answer your question?
Yeah, I don't know. I was kind of just give.
What are your feelings on AI?
I think we need to get the reins on the horse.
Reins on the horse?
Yeah.
Yeah, that's probably true.
Is there a place for it at their level? Like
Oh,
first
your
year,
level?
second year, third year, fourth year? Is there a place for it? Make education more effective?
Yeah, probably just use it for all your homework. That's a joke. So let me put it this way. I think one of the most valuable things that I did, and I just did it for fun, because this is what I find fun, and you can judge me if you want, is I've read a lot of technical documentation on a lot of different languages and a lot of different libraries. And I just read them for fun, because, I don't know, I like it. But it's actually extremely helpful, because I know a lot of niche things about a lot of different topics, and it makes you very valuable in a company. So for example, let me teach you something. Maybe you already know about this. I didn't know about this. What do I do here? Let's do this. So has anyone seen this function before?
Yes.
A couple people? Let's see what it does. It's a pretty cool function. It's actually one of my new favorite functions. This is my second favorite function in Python. Yeah, so now obviously you're using PyCharm. You say run on PyCharm, you can hit a breakpoint in PyCharm, and it'll breakpoint. And it even looks kind of nice too. And maybe there's a way to do it in VS Code. I don't know. I'm not very good at VS Code. I don't like VS Code. But everyone uses it. And it replaced Atom, was it? So that makes me sad. But anyway, so now I have this thing. And it has all these commands. And so what if I say, the AP variable, that's what this is. So then, even at work, I see people do this. And then maybe something like this. And then they'll do something like this. And they'll say, geez. What is that? And then they'll be like, I printed 3 things. Okay, and let's actually return this time. And this will work. Now I'll be able to, okay, what? And then it doesn't even work half the time. So, and I just found this function just by reading, the documentation. So, and another function I found, this is going to be a bit of a funny thing. What the flip? Okay. So I found this funny function. Has anyone heard of R partition?
I've heard partitioning. like a hard drive, but
Yeah, so partitioning is a general term. You kind of break things up into different sections. So I asked Annie, well, after I learned about this function, our partition. So what it does is it'll partition your string into a right part, a center part, and a left part. The center part is the thing you ask it to partition on. So in this case, dot. And I try to find the file extension of files all the time. And I know you can just pass it into the path object and ask it to give it to you, but that's like a hassle. What if I'm just on the command line, which I am sometimes, which I recommend using the command line Python interpreter, the REPL, it's really useful. And I just want to get the extension. And I asked Annie, and it said to do this. Dot split dash sub -1 dot split dot sub -1. And it's like, well, this is what everyone does. You know what I mean? This is just what people do. This is how I've always seen it on Stack Overflow. Just look it up. And so it just tells you what other people do, and there's always a better way. So especially at this moment, as you're learning, like it's so much better to just struggle and figure it out. So like from an education perspective, the way you learn things is through recall in your mind, and then your brain makes more pathways to the things you recall, at least if you trust education science, which I do. And so if you're just, every time you get a little confused, you just ask the AI, like, first of all, it's going to tell you things that aren't like the best. And second of all, it's like you won't, like you got to figure it out. And that's how you learn. So I would avoid it myself. I didn't need it. Well, you don't need it. I didn't need it. Jason didn't even have the internet. He's a barbarian. But it can also be kind of fun, though, you know. So, but I would embrace the struggle. That's what I would do. You know, just honor the process, honor the learning process. Yeah, it's all part of the process. Any other thoughts, comments? Yeah, what's up?
What kind of version control do you use?
I wrote a whole newsletter about this at my job. Let's take a La La Land excursion, shall we? So I'm on GitHub. I know. Terrible. I have a lot of projects. Most of these are empty, too. That's the funny part.
I don't care that you're on GitHub. I care that you're using light mode on GitHub.
I hate light mode on this pad.
You know, that reminds
Yeah.
me.
Don't do this.
So okay, I'll change it back because I know people don't like it. But I do use light mode on everything, and I don't understand people who don't. So, you know,
It hurts my eyes.
I honestly don't even know how to change it. Like I don't, and don't tell me. So yeah, so at work I have a tiered system of how to use Git. So first of all, we use Git. If that's the answer you want, I'm going to tell you more. So there's the main branch. Everything's called main now at my work job, except for a few repositories. Still on master. What are you going to do? But so a lot of projects, I straight just have main and push right to main. Especially if it's just me and it's a project that's only going to be up for like 2 weeks and it's like starting from scratch. So that sort of thing, I recommend just have main, just push right to main. It's fine. As soon as you get more than one person on the project, do you like go over pull requests?
Yeah, but if you don't mind, like, just explaining what version control is, period. Those two are first-year students.
Yeah.
Oh, okay. Have you seen this website before?
No.
Really?
I've never really seen. I know about it, but I never really.
Oh, this website's awesome. Okay, let me show you some stuff.
I mean, we have to make a LinkedIn account and Handshake account for our first year class.
Oh, that sounds dreadful. But this is way different than that. So, okay. So this is, well, actually, let me show. So this is an old version of our project that I was just showing. And we can do this thing. This is one feature you can do.
Blame?
Yeah, so you can blame people.
Oh.
Man, there's this Kory guy. He sucks. Okay, so then it says, oh, I changed this line 17 hours ago. Let's go back to that commit. So this is that commit before I changed that line. Oh, I didn't even set the random seed. What a silly guy. And looks like he's doing a bunch of other random stuff. And we can go even further back. And it's like, oh, wow. You can keep going further back. So it keeps a snapshot of every version of your file that you've ever committed. And then on top of that, what you can do is there's different names for this. But you can do something called a pull request. So let's just pretend I want to do this. Okay. So I've created a pull request. So what this is doing is it's asking me, I'm the repository owner, to get all the code from the talk today and put it into the main branch. So the main branch is like the good stuff, and the talk is like the new stuff. So I want the new stuff to be put into the good stuff. So then you can go through and you can say, okay, well, what changed? Oh, I added a new file. That looks stupid. We shouldn't include that. Oh, we changed the screen height and the screen width. Oh, yeah, that was a bad idea. It made it really slow. We deleted some full... these are good. So then we can say, okay, well, this one... I wonder if we could have better performance by keeping it equal. Let me know your thoughts, or something. And you start a review. And then you can say, oh, now I get it. Disregard above. I think this will be faster in our use case. Happy to hear more about some stuff. Generally, you want to be nice on pull requests. I was working at a job, and my manager actually sat us down and said, guys, you have to be nicer. It's your fault. We're so toxic. He was yelling at us. I thought it was very ironic. Anyway, so then it's like, okay.
Is some guy yelling at you to be more nice?
Looks great.
I put it in all caps.
Yeah.
It would show that you want to. It would show that you.
Well, I can't actually approve the pull request, so let's see if I can actually merge. That'd be funny. Okay, merge. Merge, confirm merge. Hooray! I'm going to backtrack on this, but it's okay. So now, in theory we could delete this branch. I'm not going to, because I want to keep it. But now we can go into the talk, and we can say, go into main, and now we can see, let's see, this one. So this one was just changed 4 hours ago. And so this is now in the main code. And we went through a whole review process, and it just stitches it together, and it just works perfect. Most of the time. Sometimes. Half the time. Does that answer your question about Git?
Yes.
Okay. Yeah, I guess we're about at time. Any
Questions?
final thoughts from the professors, or any last minute? I always wanted to ask this, but I didn't know who to ask.
You want to talk about Game Jam?
Game Jam. Yeah, so Travis wanted me to tell you October 10th,
Yep.
4 o'clock, for family weekend. Game Jam.
The thing that never developed a game before, so.
Great time to do it. I did my first Game Jam in freshman year myself, and
But I don't know
very
how.
Alright.
That's what Game Jams are for.
A lot of students will mentor you. Like they'll take you under their wing.
Senior year, do game jams as soon as you can. They help a lot. It doesn't matter if you don't know what you're doing.
Even if you just shadow them.
Yes.
Can we talk about I'm the only girl that showed up here?
for
For a
real.
power.
Yeah, so these are some of my games, my game jams. Some of them are even good. Especially this one. No, this one sucks. This was my very first game. We had 906 Games because we developed it in Campus View 906. It will not work. Honestly, not sure if it works. I wouldn't market your stuff that way. But, you start and it's pretty crappy, and you can have games that look like this. See if it works. Oh, I hope it works. Oh, it would be so embarrassing if it didn't work. Yeah, that's my game. Start. Yeah, this is a good game. You can, move things. You add transparency effects. Anyway, enough of that. Sometimes they suck. This one's pretty good, though. Sometimes they come out pretty good. Pico 8's pretty fun. And you got, a little thing. And, I don't know, this game's actually pretty bad.
So are you building a wall?
Yeah. Okay. This is pretty good. Anyway, I don't want to go into it too much, but they can just be stupid little things, and then you can I made this when I was 18, so now I'm not 18. I'm 29. Oh my god. So you can kind of keep track of them and put the bad ones at the bottom. Actually, this is the first game I made here, but it doesn't work because it's Flash. Anyway, yeah, I would recommend it. I might do it. If you message me on Discord, I'll make music for you. That's a true fact. Okay, that's all I got. Thanks everyone for coming. Hope you got something out of it.
Yeah.